Welcome to lesson 3, the surface areas of cylinders. Um, if you took a peek at the formulas on the formula sheet for this, you might be freaked out, but really cylinders, most people do pretty well with, especially if you understood prisms at all. So a cylinder is very similar to a prism in that there are two parallel faces. Okay, or in this case, the bases. The difference is that instead of the bases being polygons, they are circles, which we just got done with a unit on. So comes back. If you were to draw the net of a cylinder, the bases would be circles, and the lateral face, singular lateral face, or the face connecting the bases, is a rectangle. Think of a label on a water bottle. Okay, it's like a ice mountain or whatever. The water bottle's kind of in the shape of a cylinder. If I would peel that label off, it ends up being a rectangle. So that's the net of a cylinder. Okay. Recall from the last lesson that the lateral area is the area of a figure without the bases. In a prism, again, last lesson, the lateral area was pH, the perimeter of the base, times the height of the prism. What do we call the perimeter of a circle, though? Well, we call that the circumference. How do we find it? Well, there was a formula. It's 2 pi r. Okay, so I'm going to replace 2 pi r for p, because p of a circle is 2 pi r. So to find the lateral area of a cylinder, we have lateral area equals the perimeter of the base, or 2 pi r, times the height. There it is. Okay. Scroll down here a little bit. I'm going to write that again. So lateral area is 2 pi r times the height. The surface area is the area of the figure with the bases. In a prism, the surface area is the perimeter of the base times the height plus 2 times the area of the base. Well, how do we find the area of a base in this case, which is a circle? The area of a circle is pi r squared. So I'm going to replace pi r squared with b. So the surface area is the lateral area, or 2 pi r h, plus 2 circles, or 2 pi r squared. So it looks disgusting. That formula looks awful. The good news is you know the shape. If it's a cylinder, you've got a circle. The problem with, or the hard part about the prisms was the shape of the base changes. So the area formula changes. Well, in this one, it's the same thing every time. That's why a lot of people like cylinders better than prisms. And get rid of that. And the two things you need, again, I'm going to write this out. The two things you need, which is crazy, there's only 2 variables in this whole thing, are r and h, the radius and the height. Well, this one I made pretty easy for you. The radius is 3 and the height is 8. Just plug them into the right spots. The lateral area is 2 pi radius height. So 3 times 8 is 24, times 2 is 48 pi units squared. The surface area is just taking the lateral area and then adding 2 pi r, which is 3, squared. So I've got 48 pi here. We already figured that out. Plus 3 squared is 9. 9 times 2 is 18 pi. So 48 plus 18 is 66 pi units squared. Now, in true Mr. Gehrig fashion, I like to make things more difficult. So let's go to the back. A Campbell's soup can is 4 inches wide and 6 inches tall. How many square inches are needed to make the label of each of these cans? Well, you need to know how a label is, where a label is found on a can. Obviously, it's on the front. It's not on the top. You can see that in the picture. There's no red and white wording on top of the can. The can is metal. There's no paper on top of it. There's also no paper on the bottom. So what am I really asking you to find here? Hopefully you catch on that this is actually the lateral area. There's nothing covering the bases. So there's no bases being found in the area, surface area, meaning this is the lateral area. So 2 pi, the radius is 4 inches wide, so the radius is 2. Because the 4 inches wide is all the way across, so that's the diameter. 6 inches tall, that is the height. Okay, so 2 times 2 is 4, 4 times 6 is 24 pi, and that would be inches squared. It didn't say what to round it to. Let's go to the nearest tenth. So I'm just going to type 24 pi and get 75.4 square inches of paper. Okay. Not too bad if you understand what a can looks like and know the vocab. Next one, more challenging. So, what is this? So, this is the first example of this that we've dealt with in the notes. So I'm going to show you what I recommend you do. I see that I've got a rectangular prism on the bottom and I've got a half cylinder on top. Okay, so I've got a prism plus a half cylinder. Now, you remember that surface area, there's 2 types. There's lateral area and surface area. Well, in this prism, I'm going to make, you really have a hard time seeing that. Let's make them really stand out. Let's go with white. One of the few times I can use white. I'm going to make that my base, which makes that my base of the prism. With that in mind, the lateral area is all showing. All of those vertical faces are showing. So I'm going to find the lateral area of the prism. Now, are both of those bases, those white X's, are those both showing? No. The bottom one is, if I could imagine I could pick this thing up, I could show you the bottom. That one I can see. But that top one is covered up by the cylinder. I would have to take the cylinder off to see that base. So that is not included in my surface area. So I'm only finding the area of one base. Okay. Now in the cylinder, what's showing? Well, I've got the whole lateral area, which is, again, I'll go to green or to white here. This whole area here is the lateral area, right? But then the bases are also showing on the back side and the front side. So I'm doing the full surface area. So 1/2 of the full surface area. So 2 pi RH, that's the lateral area, plus 2 pi r squared. Okay, so yeah. But I am doing half of it. Gotta remember that. I'm only doing half of the cylinder. I'm not doing the whole thing. So you kind of have to piece together what you see and what you don't see. I know you're not going to like these problems, but you got to practice them. So let's do it. The lateral area of a prism is PH. The area of the base is base times height. Now, these H's are not the same. Okay, careful there. Plus 1/2 2 pi RH plus 2 pi r squared. Let's go ahead and figure out all the missing variables. So the perimeter of the base and the height of the prism. Then I need to find the base and height of the actual base. And then I got to find the radius and the height of the cylinder. So I've got 3 H's. All of them are going to be different. The perimeter of the base, I should be able to find pretty easily. Again, the base is that white X'd out thing at the bottom. So 42 plus 8 is 50, plus 42 plus 8 is another 50. So the perimeter is 100. The height connects those two white X's. So that would be 35. Now on the bottom, the base and the height are 42 and 8. So that is specifically looking at the area of the base, the white X'd shape. Now I'm looking at the cylinder, the radius at the top. So the circle is at the top, but it's kind of facing the front. The diameter is 8, shown right here, which means the radius is 4. The height connects the two bases of the cylinder. So in this case, the height is 42 because that's what connects the two circles, or half circles in this case. I know this is not easy. Stay with me. So we've got all the missing pieces. Now it's just plugging them in. So the perimeter is 100 times the height is 35 plus base times height, which is 42 times 8, plus half of 2 pi r h plus 2 pi r squared. You will be expected to do this. So if you need to rewind a little bit and kind of follow along, do it. Okay. 100 times 35 is 3,500. 42 times 8 is 336. I'm not going to worry about the 1/2 yet. I'll come back to that. 2 pi, 42, and 4. So 8 times 42. Okay, we just did that. 336 pi. Plus 4 squared is 16. 16 times 2 is 32 pi. So when I add those two together, I want to go ahead and add those. So that's 3836 plus 1/2 of 368 pi. Well, half of 368 is 184. So 3836 plus 184 pi is my surface area in terms of pi. If I said round to the nearest tenth, that would be 3836 plus 184 pi, which is 4414.1. So I'll write that over here so you can see it. 4414.1 centimeters squared. Now, I'm not expecting you to be experts on that right away. Please be able to follow it though. Okay, and keep practicing it. Don't shy away from those problems. And that's it for cylinders. I'll move on to pyramids next.